Good afternoon, everyone. Welcome back to the Java lesson 07. And in our last lesson, that is lesson number 06, we have learned about the OOPS concept, object-oriented programming system. Under OOPS concept, there are basically four main concepts. First one is inheritance and polymorphism, that is being taught by my friend in our last lesson. Today, I will take you through the another two concept of OOPS, that is abstraction and encapsulation. So first, abstraction. So as in a general, as per the meaning of a dictionary, abstraction is the quality of dealing with ideas rather than events. So what it means is, for example, if consider in case of an email. So when you send an email, you don't know what happened when you send an email. For example, the protocol behind the email server. So these things are being hidden from a user. Okay. So, but therefore, to send an email, you just have to type just an email address, then a message, then you click on send button. But you never know what happens behind the scene. That is like, for example, the protocol that email server uses, these things are being hidden from a user. So similar to that, in Java, abstraction is the process of showing only the essential information to the user. So it's a process of hiding certain details and showing only the essential information to the users. So the concept of abstraction is being achieved with either abstract classes or interfaces. I will take you through abstract classes and interfaces in detail. So before I take you through abstract classes and interfaces, so basically I will talk about the method types. There are two method types. There is normal methods, abstract methods. Okay, normal methods and abstract methods. So what is number one? What is normal method? So normal method is a method which contains method declaration and a method implementation. So normal method is a method which contains a method declaration and a method implementation. So here is an example. Here I have a void amount as a method declaration. This is a method declaration and it has a body. That body is a method implementation. So the structure of a method is called a normal method. So we have a method declaration and a method implementation. Remember that for normal method, we'll have a method declaration and a method implementation. So in case of abstract method, what is abstract method? An abstract method contains only method declaration but not implementation. So abstract method will only contain a method declaration but not a method implementation. For example, this is our abstract method M1, and it has been ended by a semicolon. So abstract method usually it has to end with a semicolon. So it is a method declaration, and for abstract method you don't have a method implementation. You don't have a method body or a method implementation. So it will have just a method declaration, and this abstract method will be preceded by a keyword abstract. So this abstract method will be preceded by a keyword abstract. So you will have this return type here. There is no return type, so it is a void. Okay, so this is an abstract method. Abstract method is a method that contains only the method declaration but not a method implementation. And abstract method will be preceded by a keyword abstract. Okay, so based on above representation of method, the classes are divided into two types. Okay, so first is normal classes and abstract classes. Based on the method representation, okay, the classes are being divided. So first one is normal classes and abstract classes. So what is normal classes? Okay, the class which contains only normal method, that is said to be a normal class. Okay, so the class which contains only the normal method. So inside a normal method, we will have a method declaration. Okay, method declaration and a method implementation. So it's a normal method. So if the method contains only the normal methods, okay, that class is called a normal class. Okay, if that class contains only the normal method, that class is said to be a normal class. So here's an example of a normal class. You have a class test. Inside the class, we have a method m1, m2, m3, method declaration m1, m2, m3, and it has its a method implementation. Okay, so this is a normal class. So what is abstract class? The next one is abstract class. The abstract class may contain abstract method or may not contain a abstract method. Remember that abstract class may contain abstract method or may not contain an abstract method. Okay, and another important point is, as for abstract classes, object creation is not allowed. If you try to create a object of abstract class, then compiler will throw an error saying that for abstract class the object instantiation is not allowed. Okay, so for abstract class you won't be able to create an object. So for abstract class, uh, abstract class may contain abstract methods or may not contain abstract methods. Okay, so for abstract class, the class name has to be preceded by a keyword abstract. Okay, so if I try to do it in a practical, so for example, okay, so normally we declare class as in this manner. For abstract class, the name of a class has to be preceded by a keyword abstract. Okay, abstract class A. So I'm giving a abstract class A, or okay, let's keep it as a parent class. Okay, so inside abstract class, it may contain a abstract method or may not contain a abstract method. So I will try to declare a abstract method. Okay, abstract method, the abstract public void. Okay, so I'm saying that, okay, car. So again, I'm trying to declare a abstract method inside a abstract class. Okay, so building. So abstract method has to end with a semicolon. Okay, so it's an abstract class. An abstract class may contain a normal method as well. So if I declare a normal method void, okay, money. So this is a normal method. In a normal method, you will have a method declaration and a method implementation. So let's keep this as a method implementation. Okay, parents has Niltrum 50. Okay, so this is the structure of a abstract class. Okay, so you have a abstract class named parent, and this name of a class has to be preceded by a keyword abstract. So inside abstract class, I have a two abstract method. Okay, the name of the method is car and a building. Okay, both returning a void return void. That means this method will not return a any return type. Okay, then I have a normal method, that is money, and inside money I have a method implementation. So usually you may wonder that there is no method implementation of this abstract method. So this abstract method will be implemented by a child class. For example, let's consider we have a child class. Okay, child class, and it has to be in order to inherit the properties of a parent class, you have to inherit using a extend keyword. Extends parent. Okay, so the method implementation of abstract method will be in a child class. Okay, so now we are going to implement the method of this abstract method in a child class. Okay, so okay, now void car. Okay, bought car void. So if you don't like implement the method in that is in a parent class, so this Java compiler will give an error saying that if we extend a parent abstract class in a child class, then we have to implement all the methods, that abstract methods that are present in a parent class. So if we don't, for example, I have implemented the abstract method car here in a child class, but I didn't implement the building abstract method in a child class. That means the compiler will throw an error saying that, okay, so the name of a class is test test dot. So see, child is not abstract and does not override abstract method building in a parent. So the error says that, so if we inherit the abstract class in a child class, that means all the abstract method in a parent class has to be implemented in a child class. So now if I implement the building method here, okay, so if we implement the building method, so now the code runs successfully, I mean compiled successfully. So what I'm trying to say here is, if we I mean the inherit a parent abstract class in a child class, okay, in a child class, that means you have to implement all the abstract method that are present in a parent class, parent abstract class. So you have to implement all the abstract method in a parent class. Okay, so this is how abstract class works. So the next one is interface. So interface, okay, interface interface is another method to achieve abstraction. The first method to achieve an abstraction in Java is abstract class. Okay, the second method to achieve abstraction in Java is a interface. So it is also used to achieve multiple inheritance in Java. Do you remember that the inheritance in a normal class is multiple inheritance in a normal class is not allowed in Java? In order to achieve multiple inheritance in Java, we use interface. So interface will achieve a multiple inheritance in Java, whereas in normal class you won't be able to achieve a multiple inheritance. Okay, so all method in an interface are declared with empty body, and all the fields are public, static, and final by default. Remember these points. All the methods in interface are declared with empty bodies. That means in the interface you won't have that normal method. Inside interface class you will always have that abstract methods. Okay, that means the method body will be empty. Okay, then you will only have a method declaration, and all the fields are public, static, and final by default. By default, the variables in the interface will be public, static, and a final by a default. Okay, so This diagram depicts the how you can extend your classes and interfaces in a class. Okay, for example, for this scenario one, you have a parent class. Okay, this is a parent class, and in usually when you inherit a parent class in a child class, you use extend keyword. Okay, you use a extend keyword. That is a normal class. Okay, you have a normal class parent a, and in order to inherit these characters of a parent class, you use keyword extends in a child class. Whereas in an interface, okay, you have for example, you have an interface class as a parent class. You want to inherit that character of a parent or the properties of a parent in a normal class. Okay, during that time, you have to use the keyword implements instead of accent keyword. Okay, so for when you have a parent class as a interface, okay, and you have a child class as a normal class, then you use implements keywords to the inherit the properties of a parent interface class. So for instance, there when you have a scenario when the parent class is interface class and also the child class is interface class. Okay, both the classes child and the parent class is a interface class. During that time, you have to use this extend keyword to inherit the properties of a parent interface class. Here in the last case, you have parent class as a interface class, the child class as a interface class. So if you want to inherit the properties of a parent interface class inside a child interface class, you use a keyword extends. The next one now, as I have already told you that multiple inheritance in Java is supported only by an interface class. Okay, so in a normal class, you won't be able to do a multiple inheritance. Okay, so in Java, multiple inheritance is supported by interface class. So for example, you have a normal class, okay, child class, normal child class, and you have a parent interface class. You have two parent interface class. Okay, this one, first one, and the second one. So you have to use that implement keyword to inherit the properties of interface class in a normal class. Okay, you can inherit multiple interface class inside a normal class. So okay, the same way, if you have a interface child class, you can inherit a interface the same way. If you have interface child class, you can extend multiple interface parent class inside a interface child class. Okay, okay, so for instance, the interface class has to I mean the name of class has to preceded by a keyword interface. So we have an interface class a. Okay, inside interface class, as I told you, that you have to have a abstract method, abstract void m1, abstract void m1, void m2. For instance, you have two abstract method inside the interface class a. Interface a, interface a inside interface. Okay, I'm defining another interface b. Okay, inside interface b, I will have another abstract. Okay, abstract That's one. Okay. Now, so another I'm declaring another interface C. This time I want to inherit the properties of interface A and B inside interface C. So that time I have to use a keyword extend. Okay, extends A comma B. This is how you inherit the interface A and B into a child interface C. Now, okay, another. So if you want to inherit this interfaces in a normal class, so let's say that this is a class test. Okay, so if you want to inherit the properties of all these classes interfaces A, B and C, you can simply implement interface C here, right? Because the interface C will inherit the properties of interface A and B. Okay, implements C. So this way the properties of a parent interface A, B, and C will be inherited in a normal class test. Okay. So when you inherit a interface inside a normal class, you use a keyword implements. Whereas when you uh, inherit the properties of parent interface inside a child interface similar to this, we use a extend keyword. Okay, this is how we use the keyword extends and implements in interface. So the main difference between the uh, abstract classes and interface, you might have seen that almost the functionality of the abstract class and the inheritance is, I mean, interface is similar. But where do we use, I mean, the abstract classes, concept of abstract classes and the interface? So if I give you a scenario, if I give you a scenario, okay. So for example, I am going to develop an app called, okay, I'm going to develop an app called my app, okay, and inside my app, I'm going to have a functionality to my get salary to get salary. Okay, the second functionality that I will have is get, okay, employee info. So in such scenario, okay, you don't know the main implementation, I mean, how you're going to get the salary of this of the employee and get the information of the employee. In such scenario, you will have to use a interface. Okay, because you don't know the main implementation of this functionality. Okay, you just know the main concept, what you are going to get inside an app, but you don't know the main implementation of the functionality. So in such cases, you have to use an interface. For example, if you know how to get the salary of an employee, then during such cases, you can use a abstract classes concept. Okay, so in abstract classes concept, if you know the partial implementation of a functionality or a method, you can use abstract classes. Whereas if you don't know the whole implementation of a functionality or a method, then you can use a interfaces concept. Okay. Okay, so the concept of abstraction is over now. So the last concept of OOPS is encapsulation. Okay, encapsulation. So when you see a term encapsulation is pretty familiar to all of us. So if I give you an example, for example, when we are trying to send a letter, okay, letter, physical letter, physical letter, that you will wrap that letter inside the envelope, okay, sealed, okay. So okay, without opening that envelope, you won't be able to get the main content in what that is inside the envelope. So in order to, I mean, read a letter inside the envelope, you have to open an envelope. So similar to the concept of this one. So in Java, encapsulation is being achieved when you try to declare the variable of a class as a private. When you declare a variable of a class as a private, the another class won't be able to access that variable. Okay, so when you declare a variable of a class as a private, the another class won't be able to, okay, the another class won't be able to get the I mean, get the variable of a I mean class that is being private. Okay, so in order to get the variable that is private in a class, it can be accessed via method. Okay, via method, that is a setter and a getter method. So in order to get access of that private variable in a class, we can get access it through by a setter and a getter method. So for example, okay, so I'm having a class emp employee. Inside the employee class, I'm going to have a, okay, name of a employee, and okay, id of an employee. So if we give a modifier as a private to this variable, then it won't be accessible to another class. So I'm going to make this variable private. Okay, so in order to access this private variable, we can get access through a getter and setter method. So for example, public string, I'm going to get the name of the employee through this method. Okay, get name, return, I'm going to return name. Okay, again, public int get id. Okay, then I'm going to, this two method will get the values of these private variables. Okay, now again, I'm going to set this variable using this setter method, public void. The setter method will not return any return type, so void set, I'm going to set this name. Okay, and this method will take a parameter string name. Okay, so I'm going to set the name equals to name void, and I'm going to set the id. Okay, int id, this dot id equals to id. These two methods will set the variables, two private variables, that is name and id. Okay, so I am declaring another class called test. So inside test, there will be a main method, static void main string Okay. So in order to get the access of this uh, method of this class emp, I have to instantiate an object. I have to create an object. Okay, so emp, okay, let's keep the name of object as emp. Okay, so now I'm going to set the id, okay, as 1, dot set name as okay, Tashi. Now I'm going to print or get the name name dot get name. Okay, I'm going to get the name, then id, okay, dot get id. Okay, so I have declared two classes. First one is class employee emp, the another one is class test, which contains a main method. So if you try to access this private variable name and id directly to the class test, then it won't be accessible. So in order to access the private variables in another class to my current class, then I have to use it through by getter and setter method. So firstly I am creating object okay, then I am calling this set id method using this object and I'm passing the integer 1 and setting the id as a 1. Then again I am setting the name as a Tashi, and at last I am getting this name and id that is being set here. Okay, so if we run this code, so it's a test. Okay, test. Mhm. Missing return statement. Where is that return statement? Okay, sorry here. I didn't define this return statement. Okay, return id. Okay, so now the code runs successfully. Okay, so this is the concept of encapsulation. So encapsulation usually means a hiding of a data. You're trying to hide the data, okay, by using a private modifier here. You are using a private modifier to hide the variable name from another classes. So you can't access directly these private variables name and id from this class test. Okay, so in order to access these private variables name and id from another class that is test, then we are using via method getter and setter method. Okay, so this is a getter and setter method. So here the public string, this is returning a string and I am getting a name. Okay, so this will return a name. Okay, this name. So this is how the encapsulation works in a Java. Okay, so now I have covered the concept of abstraction and encapsulation in Java. So my friend Tashiwanchu will take you through packages and a modifier in Java.